This is 5-2 similar figures notes. So similar figures. Similar figures, a definition. We're going to go through the definition and then we're going to go into how similar statements are written and why it is important to pay attention to them. So similar figures have the same shape, same measure of angles, not the same size. If you know that two figures are similar, you can determine missing measures, because if two polygons are similar, then they are proportional. So if I say figure so-and-so is similar to figure so-and-so, you know that their sides are proportional. Their corresponding sides are proportional. Said that a couple of times now, proportional, so it's important. And their corresponding angles are the same. Okay, that's going to help us when we set up some information. Similar figures naming gives you a lot of information. If I tell you that rectangle ABCD is similar to rectangle EFGH, this tells you that AB is similar to EF. So anytime you see this, if you see this phrase right here, what I want you to do is I want you to write ABCD, and then I want you right below it to do EFGH right below it, because that says AB is similar to EF, BC is similar to FG, CD is similar to GH. That will help you. And in some problems, if you know what to look for, that's going to make a similar problem that much easier. Okay, here we go. Elsa drew the two rectangles below as part of a design. She stated that she drew the larger rectangle first, and she used a scale factor of 1/2 to draw the smaller rectangle. So I want you to get in the habit of saying this is old, this is new. Okay, follow the steps. So we know that rectangles have opposite sides that are equal, and that the opposite sides are equal. And so if this is 3, this is 3. If DC is 6, then AB is 6. On the other rectangle EFHG, I'm going to say that the long sides, multiply it by 1/2. So this says multiply, remember multiply. And so multiplying 6 by 1/2 gives you 3. Since it's a rectangle, the opposite side is 3. I'm going to take this 3 right here and multiply it. It's the short side by 1/2, so I get 1.5 and I get 1.5. And then we can fill in the table that AB is 6 and EF is 3, and CD is 6, and GH is 3. BC is 1.5, and this is 1.5. This is oops, that is not 1.5. My apologies. This would be 3. Make sure you go back to the original. And this would be 3 and 3 and 1.5. This is old, and this is new. Are the side lengths between the two rectangles proportional? And I'm going to do new over old. So 3 over 6, 3 over 6 equals 1/2. I'm getting it from right here. And 3 over 6 is 1/2, and 1.5 is divided by 3 is 1/2, so yes. Write a similar statement. So I'm going to come back and look at my picture, and I'm going to write my similar statement right here in different color, so similar statement. I'm going to put a dot right here, and I'm going to go long, short, long, short. So rectangle A, B, C, D is similar. That's the phrase for similar. Triangle, or sorry, rectangle E, F, G, H. And so you notice that if I go along here, AB is 6 and EF is 6, so that's your similar statement. Scale factor depends on which way you're going. So be careful, because if your scale factor, and this is coming up in a little bit, but if I'm going from old to new, and I'm going by 1/2, I know because the scale factor is less than 1 that I will be shrinking. If the scale factor is larger than 1, I am enlarging. And that's going to come up in lessons later in this unit. Okay. Determine if the two trapezoids are similar. So you have to look at some of them, and you have to decide what, if they're similar. Now, this is a trapezoid, and this is flipped, and they're allowed to do that. So I'm going to come and see the slanty side, and I'm going to say that this is old, and this is new. Actually, doesn't matter who you do, because it didn't tell me who from who. But actually, I'm going to, yep. And so I'm going to get in the habit of doing new over old. Okay. So new slanty side is 25. Old is 10. Both of those are divisible by 5, so that's 5 over 2. Okay. So then I'm going to take the long side and the long side, and new is 15, and the old is 6, divided by, both of those are divisible by 3, and so when I simplify that fraction, it's 5 over 2. So far it works out. The next one I'm going to do is I'm going to go this side right here to this side right here. And so 10 to 4, those are both divisible by 2, and so that simplifies to 5 over 2. So that is correct. And notice I use different colors, because what I'm going to do here now is I have to do the corresponding angles. So angle A is between blue and green, and so between angle A, between blue and green and the other one is angle H. B is between green and nothing, and so between green and nothing is J. Angle C is red and nothing is K. Angle D is between, let's change color so we can do, between red and blue is yellow. So remember when I was talking about the similarity statement, I can already develop my similarity statement because I can go A, B, C, D is similar to H, J, K, L. Notice I went in order. And the reason I want to do that is because now I'm going to ask for corresponding sides. AB corresponds to, since AB is here, HJ is here. BC is the next two letters here, and so it's going to be JK. AD is the first and the last, so this must be the first and the last. Getting out of the name, we're going to go here. And I'm going to go H and L. And CD is these two, so it's KL. And so create proportions to prove that the two trapezoids are similar. That's what I did at the very beginning. Write a similar statement. And this right here, using that squiggly mark, is your similar. So you would write A, B, C, D is similar. See the S? Similar for H, J, K, L. Okay, next example. I'm going to have to look at this, and I'm going to see that they're not flipped. And also notice this little moniker right here. So I know that D corresponds to P. Okay, so I'm going to go D, A, B, C, P, S, R, Q. And I'm going to do new. Like I said, it doesn't matter. Just get in the habit of, if they don't tell you who's new and who's old, it doesn't matter who you label. And so I'm going to do new over old. So I'm going to go 12 is 2, and I go towards the angle moniker, which is 30. And I simplify that. It says, and I'm going to set up new is to old as new is to old. So 12 is to 30 as 16 is to I don't know. 16 is to I don't know. So I set up 12x equals 16 times 30. And that goes 12x equals 480. Divide each side by 12. And x equals 40. So then I can do this as 40. Okay, and the last problem. Notice that the triangles have some indications and some markings at the angles. And notice it goes, they're called congruent symbols. I call them smiles and double smiles. Let me move this out of the way enough. Okay. So I'm going to notice that the smiles, these have one smiles, goes to here. And then it also says that these are double smiles. So I can say triangle TCA is similar to triangle FDE. So notice TCA went from single to double to single, and FDE also goes from single to double to single. Okay, so this is new, and this is old. And remember that we are going to set up new over old to equal new over old. So I'm going to put 4 is to 8 as 2.6 is to x. And right here, I'm going to notice that 4 is half of 8, or in order to go to the denominator, I multiplied by 2. So if I multiply by 2, it's 5.2. And this is 5.2. The other way you could do it is 4 times x equals 2.6 times 8. You get 4x equals 20.8, divide, and you still get 5.2. So either way, and that is how you are going to do similar problems. Make sure you pay attention to the similar statement.